Good morning, everyone. Welcome back to Science and Math Out Loud. In the module of Materials World, this part is Polymers part. What is a polymers? Look around and you will see polymers are everywhere. From the plastic bottle that you contain the drinking water that you carry to the school. Or it may be the rubber tire for your vehicle. If you drive a car, your car bumper is polymers. For the appliance, the housing of the small appliance, it comes from the polymers. Even from your shirt, your clothes, the saving trees, it comes from the polymer as well. Oh, it's raining outside. You need something to protect your to dry. Oh, raincoat is polymer. Many things you bring to school today, you put it into the backpack. It is a polymer as well. Or when your umbrella is produced from the polymers. Or you can look at yourself. Many proteins in your body are also the polymers. To understand the words of the polymer, the polymers is come from two words. The first one is poly. The meaning of poly is many. The other word is mer. Mer is mean unit. So the polymer is mean many units linked together. In the basic term, a polymer is a long chain molecule that is composed of a large number of repeating units of identical structure. Or, from the easy understanding, you can say if you have the many small molecules that have the structure is in the same and is linked together to form a large molecule, it will be the polymer. We call each unit here is monomer. When they link together to be the macromolecule or the long chain, we call them is polymer. Again, the meaning of polymer is the many of the monomer units linked together. Polymer can be classified in various ways. The first classification of polymers is based on their source of origin. There are two main types of the origins of polymers. First, natural polymer, and the second, synthetic polymer. Natural polymers are polymers which occur in nature and are existing in natural sources like plants and animals. For the example, the proteins which are found in humans and animals. The other example is cellulose and starch. For the example, the cotton. Cellulose and starch can be found in plants. The other example is rubber, which can be harvested from the latex of a tropical plant. The other type of the polymer is synthetic polymer. Synthetic polymers are polymers which humans can artificially synthesize in a lab. Generally, it is produced from petroleum. From the petroleum, it will be converted into the polymer via chemical reaction. And after that, with the processing process, it can be converted the polymer into the products. And from the products, it can be changed the shape into the other applications. How to synthesize the polymer? The process to synthesize the polymer from the monomer we can call is the polymerization. This is the process which monomer molecules are react together in a chemical reaction to form a polymer chain. Generally, it can be divided into the two categories. The first one we can call condensation polymerization, or sometimes we call it step polymerization. The next polymerization we can call is chain growth polymerization, or the nickname is addition polymerization. The first type is step polymerization. These polymers are formed by a combination of the monomer, which usually eliminate of the small molecule like water and alcohol. The eliminate of the small molecule we generally call is condensation reaction. So that's why this synthesis or this step polymerization have the other name is condensation polymerization. The example of the step polymerization is nylon. The nylon here is named nylon 66. It comes from the combination of the hexamethylene diamine combined with the small molecule of the adipic acid and form the amide linkage here. During the chemical reaction, it eliminates the small amount of the water. The reaction of hexamethylene diamine and the adipic acid form the polymers named the polyamide, and it has the nickname or the trade name in the commercial industry is nylon. The application of the nylon is quite familiar with your daily life. For the example, it is produced for the trees, the raincoat, the backpack, and the umbrella. The other example of step or condensation polymerization is PET. PET is the abbreviation of the polyethylene terephthalate in the family of the polyester group. What is the application of the PET? It's the clear drinking water bottle that you contain the drinking water to your school, or usually you call it a PET bottle. The PET or the polyethylene terephthalate is a combination of the ethylene glycol monomer with the terephthalic acid to form the ester linkage here, and it eliminates the small molecules is water. Because it comes from the terephthalic acid and the ethylene glycol, so that's why its name is polyethylene terephthalate, or you can call it PET. This clip will be show you how terephthalic acid and ethylene glycol reaction together and eliminate the small molecules of the water and form the polyester linkage. The next polymer synthesis method is chain polymerization, or it have the other name is addition polymerization. Why is called the chain or addition polymerization? This type of the polymerization will be add the monomer time by time. You can see from the slide, if we start from the first monomer, and after that it will be linked with the second monomer unit, and then link to the third monomer unit, and so on, to form the long polymer chain. You can see the monomer unit is added time by time, one by one. That's why we call it addition polymerization, because it's the addition method. Or sometimes you can say it's like you connect the chain. Here you have the first chain and you link the second chain here, and then the third chain, next, and so on. It's a chain reaction, so that's why it will be called the chain polymerization. And why it behave like this? Generally, the polymer that form in this way is the monomers with double bond or triple bonds. In this process, you can see it will not eliminate any small molecule like the water and the alcohol. The good example is ethylene. You can see in the ethylene molecule, the ethylene molecule contains double bond, and after that this double bond can break and combine to the other ethylene and make the chain longer. For the example, this is structure of the ethylene. This is double bond. If you have some initiator or some radical, it will be attack the ethylene, and after that the ethylene will be bond with the radical, and then it will be generate the other radical. Like this. What is new radicals will be do? Yes, it will attack the other monomer and form the new bond. Like this. So you can see this one is the first monomer, and this one is the second monomer. It's same like you have first unit connect with the second unit, third unit, and so on. Addition polymerization. Again, look at this slide. Its polyethylene contains the double bond, and after attacked by the radical or the initiator, it will be connect to the second unit, third unit, and make the long chain polymer. The next example of chain polymerization is how synthesize the polypropylene from the propylene gas. Thanks to Mr. Ziegler and Mr. Natta. They produced the catalyst named the Ziegler-Natta catalyst. This special catalyst can be convert the gas from the petroleum called the propylene gas into the polypropylene. This type of the plastic is very tough and strong, and now it's very popular used in our daily life, for example, in the semi-flexible rigid container. And from their discovery, they got the Nobel Prize in the chemistry in 1963. The next classification of the polymers is classified by the molecular force. According to the molecular force, the polymer can be divided into three major parts. They are thermoplastic, elastomer, and thermoset. What is different between the thermoplastic and the thermosetting? Look at the mean of the thermoplastic. The thermo can become from the word of temperature, and the plastic is mean it can be flowable when it's in the liquid form. So the meaning of the thermoplastic is when you increase the temperature, it can be melt and make a new shape. So the origin of the thermoplastic will be solid, and when you give the temperature, it will melt and it change form into the liquid. From now, you can change the shape and let them cool. You got the new solid in the new shape. So that's why we call them is the thermoplastic. And for the thermosetting, the thermo is mean the temperature, and the setting is like the setup. The origin of the thermosetting is liquid. When the liquid is heating up with the temperature, it will become solid. And after that, when you heat it again, it cannot be melted. So its behavior look like it can be setting up or hardened with the temperature. That's why it's called thermosetting. In the polymer world, the thermoplastic is about 90%, whereas 10% is belong to the thermosetting. Another example to understand the thermosetting and thermoplastic is like the butter and the pancake. The butter is an example of the thermoplastic. At the beginning, the butter in the atmosphere is in the solid form, and after you heat it up, it will melt like the liquid that you can see in the picture. And after that, if you pour that liquid into some container and let them cool, you will got the butter, but in different shape. And how about the thermoset, like the pancake? The origin of the pancake is the starch mixed with eggs and water in the liquid state. And after that, you fry them, you heat them up, it will be cooked and change from from the liquid into the solid. And after that, it's already got the shape. Sometimes you can make it in the circle, star, or heart. And you think, oh, I don't want this shape. I want to change them. So you heat it up again. But what happened? It cannot change to the liquid. It still be solid, but it will be burned. This is a behavior of thermosetting plastic. According to the behavior between the thermoplastics and the thermoset, the application of the thermoplastic and the thermoset will be different. For the example, the behavior of the thermoplastic that can be melt and change the shape repeatedly. It will be used for the commodity plastic. For the example, the plastic in your daily life, chair, container, basket. And for the thermosetting, once it's shaped, it cannot be remelt or change shape again, so it's quite tolerant with high temperature. The thermoplastic usually apply in the parts of the unit, in the electric unit. For example, the plug or the cable. The next type of the polymer divided by the molecular force we call the elastomer. The elastomer can be think of the rubber-like solid polymer. The behavior is you can change its shape with the little force, but once you remove the force from the polymers, it can be back into the original shape. The most popular example of the elastomeric polymers is natural rubber. Natural rubber, or you can call it the polyisoprene. You can harvest the natural rubber from the heavier rubber, or you can call it heavier brasiliensis tree. It's usually found in Brazil, Indonesia, Malaysia, Sri Lanka, and also Thailand. The structure of the polyisoprene or natural rubber shown in this slide. If you can see, the chain of the natural rubber is in the green and the blue structure, and is linked with the sulfur linkage between them. This linkage is present the recovery or elastomeric behavior. Look at this structure. This is a natural rubber or the polyisoprene, and is linked with the sulfur. And you give the force to draw them apart. And what happened? The polymer chain or the polyisoprene can be slide, but it cannot be drawn apart because it's connected with the sulfur linkage. So what happened? When you release the force, it will be turned back into the original form. So you can change the shape by force, and it can be returned into the original shape. We call them like the elastomeric behavior. That's why we call it elastomer. Thanks to the elastomeric behavior of this material, A plenty of application can be used. For the example, the product require the high flexibility but want to remain the shape. For the example, the rubber glove. When you use it, each finger can move it freely, but after that, it still be in the good shape. Or even for the rubber band, or the rubber tube, or the rubber boot. They are all have high flexibility and in the permanent good shape. In the conclusion, for the classification by the molecular force, we can divide the type of the polymer into three major parts. They are thermoplastic, elastomeric, and thermosetting. The unique behavior of the thermoplastic is it can be heated up, it can be melted, change the shape, cool, become the solid. And again, it can be heat, melt, change the shape, cool, and become the solid. So you can change its shape many times. And for the elastomer, you can change its shape by the force. When you give the force, it changes the shape. But when you remove force, it will return to the original form. And for the thermoset, it starts from the liquid. When you heat it up, it will become to solid. And when you heat it again, it cannot be melted nor cannot change into the liquid. So you cannot change shape of them once it's already setting. Next, how to change the polymer into the products, or we can call it polymer processing. There are plenty of the methods to change the polymer into the products, but the most common and the most popular one is the injection molding. Injection molding is the most commonly used manufacturing process for the fabrication of the plastic parts. A wide variety of the products are manufactured using injection molding, which vary great in their size, complexity, and applications. There are some major steps of the injection molding process. The start of the injection molding process is start from close the mold, or we call it clamping. When you see from here, you can see this part is called the mold. When it's closed, we call it clamping. After that, the polymer or the red color in this gift will be charged into the closed mold. We call it injection. After the polymer is filled in the mold, we let them cool. We call it the cooling step. When it's already cool, we remove them from the mold, or call the injection. And again, the mold is closed, the polymer is injected into the cavity. After that, let them cool. When it's already cool, or solid, remove them or injection, and it will be repeated again and again. We call it the injection cycle. By injection molding, you can produce the solid polymer with different shapes. But if you want to make it hollow or have air inside them, you can use another technique called the injection blow molding. The injection blow molding is used for the production of the hollow objects such as bottles, jars, and hollow containers. Before the injection blow molding process, we have to produce preform. This preform is produced from the injection molding method that already mentioned in the previous slides. After that, like the balloon, you keep air inside this preform and make them bow. You keep air and let them bow and leave it cool. You can get the hollow containers. For more understanding, please follow to this slide. The injection blowing molding method consists of 3 stations. The first station is the injection station. In this station, this preform will be produced. And after that, the preform will be heated. At this stage, it will become soft and ready to change the shape. So, it will be transferred into the next station. We call them is the blow station. At the blow station, the mold will be clamped and trap the soft preform in the middle. And after that, the core rod will be elongate the soft preform, and after that, the air will be put inside the rod and let them blow the soft preform to grow until it fits to the mold. The next station is the cooling state. Make them solidify. Finally, when it's cool and change from the soft state into the completely solid state, it will be go to the another station, that is remove it from the mold or is ejection. And you can cut the hollow containers. In conclusion, for the polymer processing, there are plenty of them, but what I present you today is 2 of the major of the polymer processing that we call the injection molding and the injection blow molding. Okay. For the injection molding, there are 4 main steps. The first step is close the mold or clamping and charge the polymer into the mold, or we call the injection, and let them cool and remove them, or we call the ejection. Because you inject the polymer into the mold, that's why it's called the injection molding. And for the injection blow molding, you need preform. The preform is produced from the injection molding method. When you got the preform, you blow them Change the shape, let them cool, and eject. So you got the preform from the injection. You blow them in the mold. That's why this method called injection blow molding.